So hi everybody, this is Kurt Cormany with Dash America, and what I'm going to do here at this customer site is I have the new VA3 data collector with me, and I want to go out on this is standard balance of plant type equipment. One of the things that the VA3 data collector does great, and it is a VA3, is essentially a 3-channel data collector. So even though there's only 2 input channels, the second input channel is wired for 3 inputs for acceleration. So what that enables you to do is connect the triaxial accelerometer and set up your routes to where you can collect 3 channels simultaneously, an X, Y, and D plane, and in that way you can cut down your data collection and you can actually improve some of your analysis capabilities. So I have my route set up as a triaxial data collector. I have one thing to consider is when you're collecting data with a triaxial sensor, you need to make sure you keep your orientation the same every time you collect data. So typically, ideally, you would be wanting to mount targets, permanent targets on your equipment, and instead of using a magnet, the data collector itself, the sensor, has an alignment pin, and you align that pin with your target. You can connect it. That way, no matter, regardless of who is collecting the data, you're going to get consistent data, and you always know you're going to be orientated in the right direction. Now in this case, this equipment, a lot of equipment, it doesn't warrant having permanent targets mounted. So another option is to use a 2-pole magnet where you align your magnet orientation with some orientation of your sensor. So in this case, my magnet is aligned in line with my cable and the exit of my cable. So I always know that I need to mount my sensor in this particular way. Now I have my route set up in that way, so as long as I keep my sensor in line with shaft orientation, then I'm always going to have the same orientation for the axis. So what I'm going to do now is move over and collect some data off the pump and kind of illustrate how to do that. And hopefully this video will not only illustrate the benefits of this very reasonably priced, very adequate vibration analyzer, but also help you understand how you might want to take triaxial data as opposed to single axis data. Okay, so on this particular motor, like I talked about in the video when we first started, is we don't have targets here. So if you don't have targets, then it's very critical that your triaxial sensor be aligned the same way every time, so you know that your XYZ axis is the same every time you collect data. So in this case, my 2-pole magnet has the lines in line with my sensor. These units have good flat areas to collect data, so I'm collecting data just like this. I'll move over to the route. And I've collected data, all 3 channels. I move to the front bearing. Now I've got data XYZ on the rear bearing, XYZ on the front bearing. Now on this pump, depending on pump size, you may elect just to get 1 reading. If the pump's small enough, if you get 1 data point, then a lot of times that'll be sufficient for what you need to know, because as the defects propagate, you'll normally see them in a smaller pump, depending on if you're here in the front or the back, you see those defects. If it's a very critical unit, then the data becomes somewhat attenuated. So you may want to get 2 data points, XYZ on the front bearing, XYZ on the rear bearing. What you keep in mind is every time you do a data point, in this case you would double your data. And if you double your data, you double your time and double your analysis. So there's always a trade-off between how much data you collect and really how critical it is that you know that. In this case, I'm going to collect data points on both points. So I'm on the drive-in bearing of the pump. And now I'm on the non-drive-in bearing of the pump. And notice that when I collect the data, I can, as long as you keep your orientation, you can rotate 180 degrees with a triaxial sensor. It's not particularly relevant you just to make sure that your axis stays in the same plane. So I can take data here, and I can rotate this data, this sensor 180 degrees, and you're still getting X, Y, and Z, and it's relevant data. So that's pretty much completes how you would take data with a triaxial sensor on a standard piece of equipment like this. Thank you for watching this video, and I hope you find it interesting.